In this video, we're going to prove the trig identity that sine alpha over 1 minus cos alpha is equal to 1 plus cos alpha over sine alpha. Well, we are going to make a left side and right side. And what's interesting about this question is that it's unclear where to begin. We can't really do anything with sine alpha or 1 minus cos alpha or 1 plus cos alpha or sine alpha. Like there's really nothing there for us to sink our teeth into, or so it seems. But a method that you can do when you're backed into a corner like this and not sure what else to do is to get left side and right side both over the same denominator. And then oftentimes what that'll do is it'll shake free the numerators. And you'll get those in terms of the same, you'll get the numerators to be equal. So looking at this, I realize if I multiply the left-hand side by sine alpha over sine alpha, the denominator will be sine alpha 1 minus cos alpha. And if I multiply the right-hand side by 1 minus cos alpha over 1 minus cos alpha, I'll have the same denominator. So that's what I'm going to do. So this is how we begin. We multiply, like I just said, and when we do that, we end up with, on the left-hand side, sine squared alpha over sine alpha 1 minus cos alpha, and on the right-hand side, 1 plus cos alpha 1 minus cos alpha over sine alpha 1 minus cos alpha. Now look at these two denominators. They're the same. So we are trying to show that the left side and right side are the same. We've gotten their denominators to be the same. And so now we just have to compare numerators. Well, the numerators don't look the same right now. But I realized that if I was to expand 1 times 1, 1 times negative cos theta times 1, cos theta times negative cos theta, and collect like terms, I'd end up with 1 minus cos squared theta in the numerator, and 1 minus cos squared alpha, and that equals sine squared alpha. So now I've literally got the same thing on the left side and the right side, and I've proven the trig identity. I can write quad erat demonstrandum.